Hi, so I'm going to be going over my first question for the optimization assessment, which is about a soup can. And as you can see, the information given is that the volume of 400 centimeters cubed is going to be constructed of the soup can. The top and bottom cost 3 cents per centimeter squared, and the sides cost 2 cents per centimeter squared. And I have to find the dimensions that will minimize the cost producing the can, determine the cost, and prove that it is minimum. So first things first, I put my important information down. So top and bottom are 3 cents, side is 2 cents. Volume is 400 centimeters cubed, and volume is going to equal V. The cost is going to equal C, and the height is going to equal H, and the radius is going to equal R. So I drew a little picture to help me visualize, and next thing I did was create my original equation. So cost is equal to 0.03, which is the cost of the top and the bottom times pi r squared, because that is the area of the circle. And then I added that again because I need one for the top and the bottom. And then I did 0.02, which is the cost of the sides, times 2 pi r h, which is the surface area of the can. So for my side, I wanted to figure out what the height was, so I knew that volume is equal to pi r squared h for such an object. So I plugged in my known volume of 400, and then I basically solved and moved things around to get 400 over pi r squared is equal to h, which is the height. So next I wanted to figure out what the radius was, so the r variable. So first I took my first derivative. So my first derivative I used by bringing down the 2 to get 0.12 pi r minus 16 over r squared, and I did that by knowing that 16r to the power of negative 1 is the same as 16r 1 over 16r. So instead of doing, 16r over 1, so instead of bringing, keeping the negative 2, when bringing down the 1, negative 1 multiplying by 16 and then subtracting 1, I end up doing 16 over r squared just to make things easier for myself. So then I brought everything over to one side and made it equal to 0. And by solving and moving things around, I ended up getting that r, well, first if I got that r cubed was 42.44, then by taking the cube root, I ended up figuring out that r is equal to 3.48 centimeters. So to determine and make sure this is a maximum or a minimum, I took my second derivative, which I ended up getting as 0.2 pi plus 32r to the negative 3. So same thing as I did before, I brought the r to the power r cubed to the bottom of 32, so I could just make things easier and not have a negative. And then by continuing on, I ended up finding out that when plugging in my r value that I solved, which I got from up here, which was 3.48, I plugged it into my second derivative and got a positive, which means that that is going to be a concave up, and as it's a concave up, that means there's a local minimum there, meaning the value is a minimum. So lastly, I want to solve for h. So to solve for h, I took the equation that I did on my side to get h, and I plugged in my r value into the equation, and that ended up giving me 10.5 centimeters as h. So that means the dimensions are 3.48 by 10.5 centimeters for the minimum, to minimize the cost of the can. Lastly, it asked me, the screen won't fit, but it says C equals in between, in front of the equation. It just won't fit in my recording screen. It asked me to find the total cost, so I just plugged in all of my values that I got to the first equation I made for cost, and I plugged in all my R values and H value, and that ended up giving me 6.87, which means that the minimum cost is $6.87, and the dimensions are going to be 3.48 centimeters by 10.5 centimeters.